Let's talk about the zero trust network and why it is important for you to use a zero trust network. So whenever I try to use my devices along with my cloud service provider, so I just try to rely on a zero trust network, because by the definition, zero trust network provides you a trust list where you know like which kind of a client or which kind of a user are trying to access your resources. And these resources can be your cloud services which are running on AWS, Google Cloud, Azure, or even onto on-premise. Here onto the screen, you can see some of my client or my devices, which are like a laptop, iPad, and iPhone, which are trying to access the resources which are running onto the cloud service provider, which I have highlighted at the bottom, which can be AWS, GCP, or Azure. So if I'm trying to set up the zero trust network setup, so what I want is my laptop should be able to communicate with my iPad and iPhone, as well as all these devices should be able to access those services from AWS, from GCP, and from Azure. So everything is just like a local area network, but those are really isolated and those are not exposed to outside world or to internet. So it's only the trusted list of user, which can be my laptop, which can be my iPad, or which can be my iPhone, are able to access those resources. And the client which I'm talking about over here is not only restricted to my devices. I can extend this network to my friends and my families and my clients as well, so that they can also start using the same setup and they can start accessing the resources which are deployed onto the cloud, which can be AWS, GCP, or Azure. Alright, so now the question comes like how you're gonna set up a zero trust network. So for that, I'm just gonna use a Twingate, and Twingate is a zero trust network orchestrator which will help you to set up your trust list, where you can set up and specify the users which are trying to access your network or your resources. So here you can see this is your like a corporate network or your home network, and here you're having few clients which can be your internal client which you are trying to access your resources which are running onto your data center, or it can be your cloud resources as well. So as well as on the right hand side, you will find external resources or external client which are also trying to access your resources from your data center or from cloud services. So with the help of Twingate client, you can set up your zero trust network, and through which you specify that we are allowing only the internal user which are listed into our trust list are able to access those resources. And similarly, on the right hand side, if there is an external user and that user is added to our trust list, then we will allow that particular user to access those resources. So this is in principle this zero trust network setup works. And to implement this whole setup, I'm just going to use a Terraform, which is our infrastructure as a code through which we can deploy all the resources, and that will help us set up our Twingate client as well as our resources on our AWS cloud provider. Before we proceed, I would like to mention one caveat over here. If you are not familiar with the Terraform, then I have already posted a video on setting up a zero trust network using Twingate without using Terraform. So where I have used the graphical user interface of Twingate in AWS to achieve the same implementation, which will help you to understand these concepts if you are not familiar with the Terraform. Before we proceed, let's try to put down all these components into our networking flow diagram so that we can understand how this whole flow for zero trust network along with our Twingate is gonna look like. So for this demo, I'm just going to use the AWS as my preferred cloud services, which you can see over here. So this is my AWS account where I have already done the sign up. And on the left hand side, you can see this is my laptop from where I will be accessing, and my request will be originating from my laptop and it will be accessing the resources deployed inside my AWS into my private subnet. And when I say private subnet, which means that subnet will not have access to internet. Also, one more thing, and the resources which are deployed over here will not have any public IP addresses. So there are two things I'm talking about. So one is your private subnet that doesn't have access to internet, or those subnets cannot be accessible from outside, which means from anywhere in the world. So that's one. And secondly, your instances or the resources which doesn't have a public IP, and if those doesn't have a public IP, then those are also not accessible from any other part of the world. So those resources will be accessible once we set up our zero trust network, and that will be accessible from our laptop. And these network connectivity will work and which we call it as a zero trust network setup between our client machine, which is my laptop, and my cloud services, which is running on AWS. Alright, so let's take a look onto the code, and I'll show you like how in Terraform we are going to set up the AWS site first. So here, first of all, we are going to take a look onto the VPC, then we are going to take a look onto the subnet, and after that we are also going to take a look onto the resources which will be deployed inside our subnet. And these resources will also have our route table over here. These route table will be responsible for forwarding our requests. So any request which will be coming over here will be first take a look onto this route table, and from there it will land onto our resources to access those services. Okay, so I'll just switch over to my code editor, and I'll start explaining like how I'm just gonna set up the VPC, how I'm just gonna set up the subnet, how I'm just gonna set up my route table, and how I'm just gonna deploy my resources, which is our EC2 instance, which is our Linux based virtual machine. Alright, so here is my code editor, and this is my repository where I have been writing this whole Terraform code to implement the zero trust network. I'll explain each resource block one by one. So if on a first glance, if you feel this is overwhelming, then don't worry. We are just going to cover each and every resource and each line of code inside this Terraform file. Okay, so let's start first from the AWS side, and then we are going to jump to Twingate side. So first take a look onto the diagram once again. So here you can see the first thing is the VPC. So how we are going to set up our VPC. So here this is the code block for creating the VPC, and this VPC will give you a CIDR range. So this is the CIDR range I'm taking it. So what is CIDR range? So this CIDR range tells you that these many IP addresses will be allowed into this particular VPC. And the lesser the number, the more IPs you will get inside your VPC. So this is the number I'm taking to create my VPC along with this CIDR range. Okay. After that, we will be creating a subnet, and this subnet, which is this one, will be residing under this VPC. So here you can see this is the subnet block, and we need to make a reference to the VPC, which is this one. So here you can see this is the reference I have made over to this subnet, so that this subnet is created inside this particular VPC. And again, in this subnet, I need to specify the IP range or the CIDR range, which is this 10.0.1.0/24. So this is the number which indicates the IP ranges. So it will have a little lesser IP addresses compared to VPC, because if you take a look onto the diagram, then this VPC is a bigger, and subnet are the smaller units within the VPC. So of course VPC will always have a greater IP ranges and subnet will have a little lesser IP ranges. So that's why I'm using this CIDR range, which will provide a little lesser IPs inside the subnet. Secondly, there is a internet gateway. As I told you, there are two types of resources which we can create. One is the resources without any public IP and the private subnet. But for this demo, I'm just using the internet gateway, and this subnet will not be a private subnet because I'm assigning the internet gateway to that particular subnet. But anyway, when we will be doing the demo, then I will not be assigning any public IP to the instances, so that those instances will be our private instances, and those instances we will try to access from our laptop after setting up our Twingate. Okay, so here I will be creating an internet gateway, and that internet gateway will also assign within that particular VPC, which is this one. This is the VPC. Here you can see the VPC and the name, and here VPC name and the ID. Okay, so this is where our internet gateway will be created. Next is the route table. So as I told you, if I take a look onto this particular diagram over here, then here somewhere here we will have our route table also, and this route table will be able to this route table will be associated with subnet, and any request will be coming and looking into this route table, and then it will be redirected into this particular subnet. This is how this route table implementation will work. Okay, so let's take a look, and here this is the route table resource, and this is the name of my route table. It is under the same VPC. So as you can see, all the resources are getting created in the VPC. Here I'm just creating the first route. This is the route for internet gateway, so that all this particular IP range, as I written over here, allow all, which allows everyone in the world to access this particular subnet or the resources present into this particular subnet. Second is the route. Here I have created a IP6 route as well, so that I can have IP6 ranges, and after that I have also created a tag for my route table. So this particular route table will have a route for an internet gateway as well as a IP6 route to access or to provide access to internet through internet gateway. Okay, the next thing is the association. So as I told you over here, so my route table, which was over here, so this route table will be associated, this particular route table will be associated with this particular subnet. So we need to provide that association. So if you take a look over here, so let me close this one. So this is the route table association, which you can see, and here I am associating the subnet along with my route table, so that you know that this route table is responsible for forwarding the request to this particular subnet. Okay, that's done, and after that let's take a look on to one more thing. So here this is a data block. This data block is responsible for fetching the AMI, which is our Ubuntu AMI. This is, you can see. So we need to spin the resources, which is our EC2 instance within my subnet. So for that I'm just fetching the AMI ID for my Ubuntu or for my Ubuntu Linux EC2 machine. So this is where I'm just fetching, I'm just searching with this filter, and the value I'm searching with this particular name. I just wanted to have a Ubuntu with a version 20.04. Similarly, we will be fetching one more AMI, which is our Twingate. This is our resource where our services will be running. This is where we can deploy our application, resources, and everything. The second AMI we will fetch it for Twingate, and this Twingate is a resource which will be deployed inside our AWS to provide this whole connectivity and zero trust network. So this is a very specific image from Twingate which we need to download and make it available and deploy inside our AWS, which I'm just going to show to you soon. Okay, so now we have covered the VPC, we have covered the how to fetch the AMI, but we have not covered like how to deploy our resources using those AMI. So let's take a look onto that part as well. So here you can see this is our instance or the resource which we want to deploy inside our AWS. So here our EC2 machine, which is our AWS instance, which is our T3.micro, and as I told you, we are fetching using the data block our Ubuntu AMI. So here you can see the reference, which is data AWS AMI Ubuntu ID, and which you can find from here, data AWS AMI Ubuntu. So this is the resource block of data which is being used to assign that AMI ID, which is over here. All right, the instance type is T3.micro, and here I have associated the key pair. I'm just going to show you like how you create a key pair. But this key pair has been created, and this key pair is existing on top. So here you can see this is the key pair resource. So this is the public key I'm associating. So whenever you work with the key pair SSH keys, then you create a public key and the private key. The public keys are always associated with your EC2 instance, and the private key is always available with you onto your local system. I'm just going to show like how to create those keys, but that's the basic concept. And these SSH key will be used to SSH or to log in into your Ubuntu machine or Linux machine. So that's where I'm using this particular key over here. Okay, so let's go down further. So here you can see this is our AWS instance, and that we will be using for deploying our services. And this is going to be our private EC2 instance. So here, if I can write it down, then this is our private EC2 instance. And this instance will not have access to internet, but we will try to access this EC2 instance from our laptop using our Twingate client zero trust network setup. Now we have talked about this whole AWS side of the thing, so I'm talking about this particular side of the thing. So we have pretty much have taken a look onto this side, how to deploy all those resources on AWS. But now let's talk about the Twingate side. So we need to have a Twingate connector which is also deployed along with our EC2 instance, which I can show you. So but the key thing which you need to remember is that you need to deploy your own resource, which is your EC2 instance, and along with that you also need to deploy your Twingate resource, which will be responsible for setting up the zero trust network. So let's take a look onto that resource as well. So I'll close this one and I'll go back to my IntelliJ, my code editor. So here you can see here again I'm setting the same virtual machine, but this is specifically for Twingate connector. And this whole documentation or this whole code, I just taken it from our Twingate documentation. So they really have a good documentation. And if I could show you, so here you can see these are the documentation which I was referring to set up this whole connectivity between AWS and Twingate. So if you are interested in any other cloud provider, then here you can see these are the links which you can follow to set it up. But anyway, let's continue with AWS, and here you can see they have also explained like how to generate the keys, which I'm just going to show to you soon. And also like a provider, how the Terraform provider works for this Twingate. And I'm just going to walk you through soon with all of these. But anyway, what I was trying to say over here is that this is the documentation which I was referring to set up this whole tutorial. Anyway, okay, so let's get back to the topic over here. And here I have just copied all of these from their documentation, which is necessary to set up your Twingate connector, which is really specific to Twingate. But the setup is really simple. So here they are using the Twingate AMI, and then this is the instance, which is a really small one. The public IP they have enabled for this particular Twingate connector, and after that the key pair which they have assigned, the same key pair which I have generated, and I'm using it for other EC2 instance as well. And here these are the some user data, which is our like initial installation of certain packages and some variable which is needed to set up our Twingate connector. So this is very simple. It is also provided by a Twingate. So I'm just using those as a standard inside my user data script. I have not written anything special about over here. Okay. After that, the subnet, they are running the EC2 instance of our Twingate connector inside the same subnet, and here they have created some tags. So this is the one more EC2 instance which will be deployed, and this instance we don't need to touch anymore. Once we start our EC2 instance for Twingate connector, then we are just waiting to get it connected, and we are done with the Twingate connector part. And then we will just focus on to our own resources and how to connect and use those services from our local machine, which can be your laptop, which can be your iPhone, or Android phone, or iPad. Moving further, the next resource which I'm going to talk about is our group. So in the group, we are just gonna assign, and this group is gonna be your trust list, where you're just gonna assign a user which is allowed to access those resources which are running onto AWS. So here you can see this is the group, and here's the name of the group, and here this is the user ID, which is my own user ID. I'll show you from where to get this user ID. And this user ID, once I assign into this particular group, and this will act as our trust list, I would say. So this is going to be our trust list, where I can add multiple users which I'm planning to allow to access those resources. So this is where we are just going to create this group inside our Terraform code. And we can append this list also. So here you can just keep on appending the list with the multiple users, and that will keep on adding over there. Okay, so that's been done. The second thing is the security policy. So I'm just gonna stick with the default security policy, but you can customize, which I'm just gonna show you from the GUI of our Twingate as well. So that will be more easy for you to understand. And after that, this is our Twingate resource which will be deployed. I'm just going to show that resource also. So we need to have a connector, we need to have our resources, and we need to have our group, and which we call it as a trust list. So these are the resources which we need to deploy, and these resources is gonna tell that which ports are open and which ports are not open. So here you can see we are allowing the ICMP, the ping, the 22 port, and as well as the UDP allow all. So these are the ports which we are allowing to access onto our EC2 instance, which we will be deploying soon. And here you can see we are also adding the trust list, which you can see over here. So this is our trust list which we have created, which you can see over here, group, and here we are just using that particular trust list inside our this Twingate resource so that it is mapped properly. And after that we are setting it to true. So these are the resources which will be created once we apply our Terraform apply command, or when we are gonna see and execute these commands from our terminal. Okay, so now coming back on top of my Terraform file, so there are a few more resources which I have not explained, so take a look on that one also. So here we are just gonna create a network also. I'll just show you from the UI. It is really easy to understand. And then this is the connector, and this is our connector token, which you need, which Terraform will generate and use it for our network connector. Anyway, so these are the resources which we will be provisioning using Terraform. Now let's take a look onto the GUI of our Twingate and how to connect all these resources with our GUI. So here I'm just going to go back to my browser, and here you can see this is our Twingate homepage. And if you haven't done the sign up, then please go ahead and do the sign up, because the sign up is quite simple. And with Twingate, you will not be charged for your initial uses if you are like lesser than 5 users, and if you are having more users, then there are certain plan. But for initial or like users which just want to try the Twingate for their personal uses, then it's absolutely free. So these are some pricing which are associated with the Twingate if you are interested in looking some higher plans. Anyway, so let's go ahead. So I have already done the sign up for Twingate, and the sign up is really simple. You just need to use your email ID if you have your personal one. Otherwise, you can just go with the authentication from a Google, Microsoft, GitHub, or LinkedIn as well. So I'm just going ahead with my Google account, which I have been using to do the sign up. So I'll just go ahead. And this is the default dashboard which you will eventually see once you do the sign up. And here I'll just first show you, like I have already deployed all of the resources, so I'm just going to first show you how it looks. Then I'm just going to destroy everything and recreate everything from the scratch once again from Terraform. So here you can see the first thing which you will notice over here is the deploy connector. So if you click on it, then here you can see our one connector is already deployed. So whenever you go from UI, then you need to create a connector, and once you select this connector option, then you need to choose the option. So here I'm just choosing AWS AMI, and here you will see the access token and refresh token which you need to get, and after that it will give you this user data script to run it manually. But right now I'm doing everything from a Terraform, so all of these are created over here, which you can see. This is our connector, this is our network, this is our connector, and here I'm just getting those tokens. And once it is deployed, then you will see this connector over here, this remote network over here. And in this remote network, you can see there are connectors. There is only one connector I'm running, but for high availability, you can deploy both of your connector into your AWS. So here you can see one connector is running and it is connected, and this is connected to my AWS EC2 instance, so which I can show you also over here. So this is my AWS console. Go to our EC2 and click on this instances, and here you can see both of it. So this is our connector from Twingate, and this is my demo machine, which is my personal EC2 instance which I want to access. And if you click on this instance, then here you can see there is no public IP assigned to it. There is only private IP assigned or associated with my EC2 instance with this IP. So this EC2 instance is not accessible from anywhere unless and until I have the Twingate setup, and which will allow me to access this private EC2 instance. All right, so coming back over here, so I have shown you like a connector, I have shown you network. Then the next thing which I would like to show you is the resources. So here you can see this is our resource, and here you can see this is our group, which is our AWS demo group. And if I click on this demo group, then you will see this member. So this is our trust list where I'm allowing the user to access this particular service. So as of now, I'm allowing myself, but here I can keep on adding the user into the trust list so that they can access these particular services which are deployed onto AWS and running via our Zero Trust Network setup using Twingate. Before we move, I would like to show you how I have generated the SSH keys. So here you can see this is the SSH key which I promised to show you. So I'm just going to open the terminal over here. Let me drag the terminal over here, and here I'm just going to open the new tab, and here you just need to enter the key SSH keygen. And after that, let me copy the path first of all. I'll just do the pwd, and yeah, I'll just choose this path over here. Okay, let's start again. So how I generated this SSH key. So you just need to run the command like SSH key gen and then hit enter, and then it is going to generate the key for you. So here enter the file in which you want to save. So I'm just gonna paste the path which I have just copied, and here I'm just gonna put the test key, the name of my particular SSH key pair, and hit enter. Do you want to put any passphrase? So I'm just gonna skip it, and here you can see our key has been generated, which I can show you also. So here I just need to run the lslart, and after that I just need to paste the path and then hit enter. And here you can see the key has been generated, which is this one, test key. This is our private key without any extension. If you don't see any extension, this is our private key and this is our public key. So this is how I have generated the keys. And here I'm just using, this is the key which I have already been using for other of my demos. So that's why I'm just sticking with this particular key. But anyway, the concept is really simple. Just generate the key, attach this public key over here, and keep the private key with your own or onto your own laptop or the work machine from where you want to access those EC2 instances. All right, so let's destroy everything from our terminal. So I'm just going to clear the screen, and here I'm just going to run the command terraform destroy, and let's put auto approve because I know what I need to destroy. But keep in mind, you don't need to always use auto approve because it might delete quite a lot of dangerous resources, and you might lose your quite a lot of resources which are running into your production dev or QA environment. So be careful. All right, so after a couple of minutes, all the resources has been deployed. So let's get back and verify onto our first of all onto AWS. So if you go over here, then click on this EC2, and here you can see 0 instances running. So all of the resources has been destroyed. And let's go back to our Twingate, and here you can see all the connector and everything has been destroyed and removed. So if you take a look onto, then here you can see all the list is empty, all the resources are empty, and there is no connectors which are running. So our whole setup is wiped out, and let's start again from the scratch. So now what I'm just gonna do, I'm just gonna go back to my ID over here. I'm just gonna clear the screen. The first command which I'm just gonna run is terraform init. That has been successful. I'm just going to clear it. The next command which I'm just going to run is terraform plan, and it is going to tell you like how many resources it is going to add. So it is going to add 13 resources. After that, I'm just going to clear this one, and the final command which I'm just going to run is terraform apply. And I'm just going to supply the suffix auto approve so that I don't need to manually approve because I know what are the resources it is going to deploy, and then hit enter. and it will take a couple of minutes to deploy all the resources. So I'll be back once these resources are deployed. So after a couple of minutes, all of my resources has been deployed, which you can see over here, which are running green now. So let's take a look onto the dashboards one by one. So first of all, let's refresh the AWS side. So I'm just going to refresh it over here. So here you will see two resources. So one is the Twingate connector and one is our demo VM, which is our EC2 instance where our services will be running. Let's take a look onto this instance, and here you can see there is no public IP and it's only the private IP. So we are just going to try to access this EC2 instance by using the ping command from my local laptop. That we are going to verify it. But now we have seen the AWS side, and let's take a look onto the Twingate side of the thing, how the resources are deployed over there. So this is my Twingate side, and I'm just going to refresh it, and here you can see it will just show one connector which is connected. And if we take a look onto this particular connector, then these are the details of our AWS region, which is our AWS EU West London, which is the name of this particular connector which I have used. And after that, I'm just gonna go back and let's get back to our dashboard, and here you can see the resources side. So here on the resources side, you can see this is our resource which has been deployed, which is our AWS demo server, and the IP is 10.0.1.161, which you can see, which is same, which is over here. Okay. And if you take a look onto this one, so here is the demo group, which is our trust list, and to the trust list you can see this is my user, which is present over there. So all of our resources has been deployed. So how to test it? So to test this whole setup and try to access this particular private EC2 instance from my local machine, I need to install the Twingate client. So how to install that Twingate client? So if you go over here and just on a Google search for Twingate client, then you will find a download Twingate client option, and here you will have all the options available to you. If you are using Windows, Linux, Chrome, iOS, Android, then all the options are there. So here I'm just using MacBook, so I have already downloaded my Twingate client, and I'm just going to show that Twingate client to you. So which is this one. Let me open that. So here you can see this is the Twingate client. Once you download and install, then this is the UI which you will get after your Twingate client is installed. So you just need to click on continue over here. So I have already done the sign up, that's why you are not seeing that particular signing button. But once you have done the sign up, then you need to use your sign up email ID for connecting your Twingate client. So here you can see on the top of this particular bar, because I'm using Mac, so here you will see the option for our Twingate client which has been installed and running. And here you can see this is the same email ID which I'm using, which is rahul123wag@gmail, and this is already connected to our AWS demo server. And this server is the same server which I have deployed, and just make sure that this dot is green. Sometimes it is red. For that you just need to go and authenticate again with your email ID through which you have registered. So once this Twingate client is connected, then you should be able to access or ping your EC2 instance. Alright, so here is my terminal. So I'm just going to copy the private IP address of my EC2 instance. So this is the EC2 instance. Copy the private IP address, go to terminal, type ping and paste the IP address and hit enter. And here you can see I'm able to ping my EC2 instance. And this is how this whole connectivity works between your local laptop using the Twingate client, and now I'm able to access those private instances from my local laptop using our Twingate Zero Trust Network setup. Let's test the same setup on my iPhone. So here's my iPhone, and here I'm just going to open the Twingate client first of all. So this is the Twingate client, and here I just need to click on sign in and connect. Continue. Use my Gmail ID to authenticate. Click on continue. And once it is authenticated, then you can see this is the AWS demo server which is visible over here, and it is connected now, which you can see. And I'm just going to copy the address from here, and here on the on my phone, I have already downloaded one utility, which is like a SSH or terminal utility for my iPhone. And here I'm just gonna type the address command, which is ping, and after that I'm just gonna paste the IP address and hit enter. And here you can see I'm able to ping successfully my EC2 instance from my iPhone, and which is using our Twingate client. Alright, so this is how you're gonna connect your own laptop and your own mobile using the Twingate client to access those private resources running onto your AWS cloud environment. But you can also connect the same way using GCP, Azure, and even onto your on-premise resources as well. Well, that was just an example, but you can still use your iPad or your Android tablet also with your Twingate client, and it should work flawless. So I hope this whole tutorial on zero trust network setup to understand like how this whole concept work and how you can leverage this Twingate client to set up your own zero trust network. If you really enjoyed this session, then please hit the like button and please consider subscribing to this channel. And if you have any question, just put down into the comment section, and also reach out to Twingate if you have any further queries related to their product. So see you into the next session of our DevOps. Till then, take care and bye bye.